All right. So if you guys wanted to watch this on YouTube Live, that's the link there. It won't work on Chromebooks, like I said before. But if you're on your own PC or if you want to pull it up on your phone, it'll be a lot higher quality. And I'm hoping that the audio is working on that, because I did this during first block and there was no audio. All right. So let me move the audio over here. Okay. So in this problem, we have a car that's traveling 150 meters per second, and it stops in a distance of 65 meters. And it's asking, what is the acceleration? So what acceleration caused it to go from 150 meters per second to stopping in the distance of 65 meters? Okay. So the first thing that we do with problems like this is we go through the problem, and I have a template that I'm going to try to find on my flash drive that kind of it's a little guide on how to go through problems like this. So I have it sectioned off in different blocks. So the first block is for the problem statement. And what I do is I typically rewrite the problem statement. And as I'm rewriting it, so I would say a car is traveling, and then whenever I get to a point where I get a number or like a magnitude, I immediately, like after I write down what the magnitude is in the units, I immediately come down here to my knowns, like the known section down here, and then I write down 150 meters per second. And then I'm like, all right, so 150 meters per second, that has to represent one of these variables over here. Let me scroll down just a tad. So it's either going to represent my displacement, which has units of meters. It's going to be my initial velocity, which has units of meters per second. My final velocity, which is meters per second. My acceleration, which is meters per second squared. Or my time, which is units of seconds. So if I look back over here, I have units of meters per second. So it's going to be either my initial or my final velocity. And if the car is traveling 150 meters per second, that's saying that I'm starting off traveling 150 meters per second. So this is going to be the value for my initial velocity. Okay. And if you guys have questions or you need me to re-explain something, I can't really see the chat right now, so just unmute and let me know if I need to reiterate something. Okay. So after I've written down and figured out what this magnitude and unit are associated with, like what variable it's associated with, I then continue on writing the problem statement. So it'll stop in a distance of 65 meters. So the unit of meters is a unit of length. So if I look back over here, the only one that has units of length would be my displacement. Okay. So that's going to represent D, my displacement. So it's going to be 65 meters. And that is representing my displacement. Okay. So you'll notice that I have another dot here, and I'll get to that in a second. So it's then asking, what is the acceleration? So then that's when I come down here, and I'm like, what is my acceleration? And that has to be in meters per second squared, because that's the proper unit for acceleration. Everybody good so far? Is anybody confused or lost at this point? It should be pretty straightforward. Okay. So my next question is there any other piece of information that's given to us in this problem that's not explicitly given as a numerical value. What's the key word in here that kind of clues you into that?
Stops.
Yeah. So it stops. So what that's telling me is that my velocity when I finish, when I finish this whole scenario, my velocity at that point is going to be 0. So that means that my final velocity in this case is going to be equal to 0 meters per second. Does that make sense?
Yep.
Okay. So this is where I don't want to say the difficult part of physics, but this is where people get lost, and this is where people get intimidated by physics. So now that we've gotten all the information that we need from the problem, we need to figure out how to solve for my acceleration. So this is where the equations come into play. So I want an equation out of these 4 that only has my initial velocity, my final velocity, my displacement, and acceleration. Okay. So if I switch back over here, can I use this first equation here? Am I able to use this to solve for A? It has A. It has initial. So why can I not use this one?
Because it has time.
Correct. It has time as a variable, and I don't know what time is. Can I use this second one?
Yep.
Yes. So I know velocity, my final velocity. I know my initial velocity. I am trying to find my acceleration, and I know my displacement. So this one's looking good so far. This one has time in it, so I can't use that. And this one has time in it. I can't use that one. Does that make sense? Okay. So, like I said, I'm going to upload that document once I finish tweaking it and making it so it's easier to read. Because right now, I did the dirty work and I got all the equations done, but it's not easy to follow. So I want to make it so it's nice and pretty for you. But what we're going to do is I'm going to write that equation. Okay. So it's my final velocity squared equals my initial velocity squared plus 2 times the acceleration times my displacement. Okay. Now, when we are doing a problem like this, like I mentioned in the video for the Edpuzzle, what you've been taught is when you're given an expression like this and you're given values for the variables, you were previously told to plug in the values for whatever you know and then solve for the variable that you're looking for. Okay? That is not the way that it's supposed to be done. It can be done, but you're going to be doing a lot more work in the long run. So, what we're going to do is we're going to solve this algebraically first. We're going to solve it for my acceleration first. And then, once we have acceleration on the left side of the equation, or by itself, and all the other variables on the other side, then we're allowed to plug in. Okay? So I'm going to go ahead and copy that. And then I'm going to do this. Okay. So when we have problems like this, there's going to be some terminology that I use that may be a little bit different from what you guys have heard before. So I'm going to use a term, or I'm going to use a phrase. I don't want to say this. I'm going to use the word term to represent this. Any grouping of variables that is separated by an equal sign, an addition sign, or a minus sign, that's what I'm going to refer to as a term. Okay. So I have a term here. I have a term here. And I have a term here. So this expression has 3 separate terms. Is everybody cool with that? Okay. Now, this is where it makes life a little bit easier when we're using this phrase term. So the term that has the variable that I'm looking for, I'm going to keep that stationary. I'm not going to touch that until all the other terms on that side are moved to the other side. Okay? And I know this is really basic algebra, but I want to do this so there's no confusion whatsoever. Okay, so this term right here, I'm going to keep it stationary. I'm not going to touch anything with the 2 or the d or the a, okay? Whatever's left over would be this, the v sub I squared. Now, since this term and this term are added together, in order to get rid of the v sub I squared, I have to subtract v sub I squared. And I do that on both sides of the equal sign. So this would be minus v sub I squared. Is everybody okay with that? Oh, I apologize. I'll move back down in a second. So it will cancel on this side. And then I'm going to rewrite the expression. So I'm going to have v sub f squared, and then it's going to be the minus v sub I squared equals a positive 2 times my acceleration times my displacement. And what I like to do is I like to keep the variable that I'm solving for in a red box, or just keep it boxed. That way I don't lose track. Okay, so in the event that I only have a single term that has my variable in it, that is the time that you can divide and multiply to cancel out variables. Okay? If I still had it like this, I would not be able to divide or multiply by anything to cancel anything out, because I have this term and this term up here. So the only time you can multiply and divide is when you have a singular term on that side. So because I've got 2 multiplied by a multiplied by d, in order to get rid of the 2 in the d, I must divide by 2 times d. Let me move this over a bit. And if I do that on the right side, I must do it on the left side. So I have 2 times d. On the right side, the 2's will cancel, the d's will cancel. So now I'm only left with the variable that I'm looking for, a, and everything else on the other side is good. So what I'm going to do is I'm going to do 2 more steps. I'm going to rewrite this so it's easier to read. So I'm going to have final velocity squared minus my initial velocity squared all over 2 times my displacement. And that is going to equal my acceleration. Does that make sense? So when we have expressions like this, we don't typically have the expression and then the variable that it's equaled. You know what I mean? So what I'm going to do is I'm just going to flip sides, which doesn't change the expression at all. So my final expression for this is going to be my acceleration is equal to my velocity squared minus my final velocity squared minus my initial velocity squared all over 2 times my displacement. And move it down a little bit. Okay. Is everybody tracking so far? Does everybody see how I ended up solving this algebraically without using any of the stuff that they gave us in the problem? Okay, so how long did it take me to do that algebra? I mean, I went a little slow, but you guys would hopefully agree that that took more time than it needed to, yeah? Wouldn't it be nice if somebody that you knew took the time to go ahead and do that algebra for you? Oh, would you look at that? So, after we get to this point, before we start plugging in the values, let's verify that on the left side, over here, the variable that I'm looking for, the variable that it's asking to solve for in the problem statement, is on the left side. It's by itself. So the variable that they're asking us to solve for is A. And that indeed is on the left side. That is over here. So this gets a check mark. Now, the only things that should be located on the right side of the equation, these variables here, I should only have variables that are located in my knowns category. Okay? If I have a variable in here on this side, so say if I wasn't given the distance, then I'm not allowed to plug in the values to get my result. I have to figure out some other kind of expression to plug in for D. Okay? Because we don't want to do intermediate calculations. But we'll get into that later. In this case, we are given my final velocity, we are given the initial velocity, and we are given the displacement. So I've got check marks through all of it. I am now allowed to plug my values in. So when I do this, this part right here may seem tedious, but I promise you, if you rewrite it, it will save you a lot of strife and heartache because it will prevent you from making this a plus by accident or forgetting to put a square, you know? So I take wherever my parentheses are and I copy that down without the variables, and wherever the variables were, that's where I plug in the values. So my final velocity, I look back up here, my final velocity was 0. And because these units here are already the proper units, like velocity has to have meters per second, distance or displacement must have meters, and so on. Because they're already in the base units, I don't worry about putting the units in here. So my final velocity is going to be 0. My initial velocity is going to be 150, I believe. Yeah, 150. And then my displacement is going to be 65. Okay. And just to prevent any kind of calculating error, 0 squared is just 0. So I'm going to write this a little bit cleaner. I'm going to kind of simplify it a little bit. So this part just goes to 0. So I'm going to have negative 150, but make sure that when you're putting this into the calculator, you're not squaring a negative 150 like this. So negative 150 squared is not equal to that. Okay, so you have to have the parentheses because this is squaring the 150 and then making it negative. If I do this, it's doing negative 150 times negative 150, and a negative times a negative makes it a positive. And then I've got 2 times 65. And has anybody done that already? So it's going to end up being approximately negative 173.08 meters per second squared. And that's going to be my acceleration. And then whenever we get our final answer, I'm going to ask you guys to box the answer. Okay. Now, because we're virtual right now, this whole part, like boxing the answer and stuff, that's kind of irrelevant. But when we get back into the classroom, whenever that should be, that's how I want you guys to kind of do it. Cool? All right. So this, come on. So this is what the problems look like. Now, imagine how much quicker we can get through problems if we didn't have to do any of that. Do you see how much simpler the problem will be? If this was gone, we would only have to do this part. And I didn't have to do any algebra. I would just have to find the proper equation, just figure out what I'm solving for, and then figure out which variables I have. And then I choose that equation and then I plug it in. It's that simple. Switch back. There we go. Okay. So, how do you guys feel? I know that this is kind of like your first introduction to this kind of stuff, but if you guys can give me some feedback and let me know how you feel about this process. Do you guys understand how much easier it's going to be if we use the stuff that I'm going to provide to you? This stuff. Do you guys see the importance of that and how valuable that is?
Yeah.
Okay.
I feel like I kind of know what I'm doing, but I just need to practice more.
Yeah. Okay. Okay. So how about this? And I'm making this so I can post this online for you guys. All right. So let's go through this here. So this is from the Edpuzzle. So if I'm riding a bike downtown with a speed of 15 meters per second and you see a red light ahead, you gently brake over the distance of 50 meters and come to a complete stop. What is your acceleration during this time? Okay. So I'm going to write down what I know. I'm going to figure out what I need to find. And I'm going to then write down any valid equations that I think will be helpful. Now, this part is important because if you don't do that, the chances of you miswriting or rewriting it incorrectly goes up exponentially. So if you copy down the original equation that you're trying to do that you're trying to use, you can go back and reference that whenever you need to double check to make sure you're doing things correctly, instead of having to be like, oh, where's my formula sheet? Okay. So if I go back over here, so we've read through it. Now we're going to go through and look at the numbers. So you're writing down blah, 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 and then speed of 15 meters per second. So the 15 meters per second is a unit of what? It's a unit of velocity. And if I'm already traveling 15 meters per second, that's indicating that it's my initial velocity. Switch back. And then I see a red light. I gently brake over a distance of 50 meters. So in this case, this represents my displacement, but in this situation, my distance and displacement are the same thing. So 50 meters. And then the last part, keep hitting the wrong button. And then I come to a complete stop. So whenever you see the word stop or rest, that's indicating some information about our velocity, whether it be initial or final. We already have information about my initial, so we can therefore conclude that this is referring to my final velocity of 0 meters per second. Cool? And then the question is asking, what is my acceleration during this time? So how many people are like, hey, this sounds really familiar? That should be everybody. This is very, very familiar. So this is kind of what I was pointing out. So if you remember how long it took me to do that last problem, it was mainly because I was explaining everything. But now that we know that these are our knowns, initial velocity, displacement, final velocity, and then I'm asked to find my acceleration, this is the exact same situation as what we currently have. So I don't have to do all that algebra that I did before. All I have to do is refer to this equation here. My acceleration, this one right here, is my final velocity squared minus my initial velocity squared over 2 times my displacement. So this is the equation that we're going to be using. Now, when we do this, it's a very good habit to rewrite. I know it sounds tedious, but I promise you it'll save you in the long run. To rewrite the original expression, and just to verify that we're allowed to start plugging in values, the only thing that's on the left side of my expression, this should be my find, which it is. So that gets a check mark. And the only things that should be over here should be located in my knowns. So v sub I, yep. Displacement, yep. And velocity, final, yep. So I get check marks all around. So I am now allowed to plug in. And then the values that I get, so initial velocity right here, so I get 15. Displacement is right here, that's 50. And then my final velocity is 0. Okay, so like we did before, just to make life super, super easy, this part right here, this part of the term goes away because 0 squared minus whatever. Is this gonna be on YouTube? Yes, I'm doing YouTube live right now. Um, it'll hopefully be done processing within like an hour. So if you go to my YouTube channel, you should be able to see it. After that, that's part of the reason why I like doing the YouTube live, because when I circle something and then I erase it, it still copies, like it still records that, and it's gonna be a lot higher quality than what you guys are seeing on Google Meet. Yeah, I'll throw some. I'll see if I can find a worksheet that has a bunch of practice problems, and then what I'll do is I don't know if I want to record myself doing the solutions to it, or if I'm just going to write out the solutions. I haven't decided that yet, but I will give you guys a bunch of practice problems. Cool. All right. Okay. So let's do this. So this should be 15 squared over. So let's go ahead and simplify this denominator right here. So the 2 times 50, that's just going to be 100. So 15 squared is 225. And then I have the negative outside of that because this square is only applying to the 15. It's not being applied to the negative. Okay. So I get a negative 225 on top divided by 100. So what I end up getting as my result is a negative 2.25 meters per second squared. And that is my acceleration, or more appropriately, my deceleration. No, I guess that's right. So I have a negative acceleration, which means I am technically decelerating. But when we refer to acceleration in physics, it's always going to be the term acceleration, and then we're going to indicate if it's positive or negative. We don't like to use the word decelerate. We'll say a negative acceleration. Does that make sense? Just to keep things consistent. And then lastly, I'm going to box the answer to the problem. So look at that problem and compare it to this problem. So this looks much more intense, even though they're the exact same problem, just with different values. Doesn't this look a lot simpler and a lot more elegant? Yes, Mr. Applewood, it does. Thanks for doing all the algebra for us. Really appreciate that.
I have a question.
What's up?
Do you talk to yourself often or just during this class?
No, I do it all the time.
Do you answer yourself?
I do.
Okay. That's it. That's yeah.
I mean,
I'm gonna comment on it because that's the same.
Say again?
I mean, I do the same thing, but
Did you grow up by yourself? Like, did you have like anybody when you were a kid? Like any friends or anything?
So I had brothers, but I didn't really have a lot of friends.
Yeah, but like, were you like really close with your brothers?
Not particularly, no.
See, because I think that's why I do it. Because like, I was an only child for like the first 10 years, so I feel like I do that because of that.
Well, I mainly do it just to get you guys to react to know it's something that's weird that you guys are like, oh god, that's pretty cringy.
I mean,
And
I
it
have
worked.
friends.
Look, you guys
I
are
do
talking about it. What now?
I mean, I have friends, but I still talk to myself and answer myself because some of my friends don't comprehend the questions I have.
Oh, your brain just that big?
Yeah, they're not as intelligent as I am.
Oh,
Yeah, one of them's in this class, but we're not going to mention that.
oh gotcha. Okay. So how does everybody feel? Like in the chat, 1 to 10, like 1 being I have no idea, I'm completely lost. Like send some help. And then 10 being I get this completely. I don't know what is going on with my There we go. No, get back on there. There we go. 10 being given that we are allowed to have more practice, I feel like I can do really well. That would be number 10.
8.5.
8.5? Okay. Just Stuart? Is everybody else asleep? Hans, how do you feel? There we go. Brian, how you feeling about it? Okay. So, let's see. So with the 5s and 6s, what makes you more apprehensive? Like, what's making you feel like you don't quite grasp it? Like, do you need more examples, like me explaining it, or do you need to just do some examples on your own? Like, how can I make it so you guys understand it better?
I don't know for everyone else, but for me specifically, if I do like some on my own, like, and I don't get it, and I do my own research to get it, it'll help me learn a lot better.
Okay.
I also feel like there's certain that you just can't make people understand better than they already do.
What now?
If that makes sense. Like, there are just some things that some people are, like, can't comprehend better than they already do.
So when it comes to stuff like, I mean, with that logic, I mean, teaching would be pointless. You know?
It sort of is.
Well, I mean, not necessarily. Like, I mean, if you learn a new trait or like a new skill or a new technique for something, like it's not necessarily academic learning, but it's something that you didn't know before. And the fact that, like, the whole concept of, some people just can't learn these things it's not a thing. Like, you can learn, you just need the proper teacher. And luckily for you guys, I'm a really good teacher.
You're very right. You are very right about that one.
Yes, I know. I think I'll understand when I do that puzzle. Okay. So yeah, with the I feel like I just get the equations confused and probably. Okay. So when it comes to, like, that's what I was saying when it comes to the problems like this, the hardest part, the part where people get I don't say turn off from science because that sounds weird, but when people get discouraged with science and when it comes to math and stuff, it's because not only do they not have the proper practice techniques, but they're not given the proper tools or guidance on how to figure out the problem. So it's not like here's a situation and it's going to work like this all the time. That's not how math works. It's not how physics works. But if you can recognize the characteristics of a particular problem, you can be like, all right, so I know how to break this problem down so I can figure out what I know, what I need to find, and then I'm going to use the tools that, my awesome teacher provides me, and I'm going to use these tools to figure out which things I need to use to solve for what I'm asked for. Okay. So it's really frustrating when it comes to math and stuff like that, because the way that math has been taught is very black and white, and here's some examples, and if you don't understand it, then you're SOL. So that's why I kind of like this, where I'm able to record this, you guys can go back and watch it. And I don't know if you guys are able to watch the video after it's gone live and it's now available to watch anytime. If that's not the case, then what I can do is I can try to import it into Edpuzzle so then you guys can watch that. And I won't make that a grade. I'll just make it available for you guys to access. Does that make sense? And if it doesn't even do that, then what I can do is I can download it from YouTube and then upload it to my Google Drive, and then have it in Canvas for you guys to go back as a reference. More steps, but I'll do what I need to do so you guys can have as much background information as you can. Cool. All right. So let me double check and make sure. I think everybody has taken the assessment. Let me just verify that. All right, give me 1 second. All right, Joanna, you weren't here? Okay. Let's see, grades. So the people that need to take the assessment that we did last class are Joanna and Chad. Yeah. Okay. So Joanna, are you cool if I go ahead and unlock it? Are you cool to do it, like, to complete it today? Okay. All right. So I'll go ahead and do that. But other than that, does anybody else have any other questions? So tonight, I wanted to let y'all know. Let me find the website. So they're going to be deciding whether or not we go back to school November 9th. Like, they're having the meeting tonight. So I'm going to find the link for you. Here it is. All right, so I'm going to put the link in the chat in case you guys wanted to watch it live. Copy this URL. They start at 6:30. So for those of you who are not wanting to go back because of all the stuff that's going on, I do want to let you guys know that if you are deciding to come back, it's not going to be the typical high school experience. Like, there are going to be, I have to watch what I say. The protocols that they're going to be implementing are going to make it very difficult, and let's just say that it's not going to be enjoyable. Okay, so I wouldn't recommend choosing to go back unless you absolutely have to. It's not going to be you guys catch what I'm saying, right? Like, you had to go from one class directly to another class, and like, some of the hallways are only one way. So you may have to do like a weird loop to get to the class that you need to get to. You have to wear your mask at all times. Like, the bathrooms will be closed during the class changes. So you have to go during class. While you're in the restroom, there's going to be a teacher in there to monitor that people aren't taking their masks off and that people are properly washing their hands. There's just going to be a whole bunch of stuff. And if you guys are choosing to go back because you want to get back to normalcy, I understand that. But what I'm trying to let you guys know is that it's not going to be anything that you're expecting. And once you make that decision, then you're locked in. Like, you cannot change it. So, I don't know. We'll see what happens. And
my question is, how long are they going to be able to keep up with staying on people's behind over stuff? Like, I just don't see them being able to be on people's behinds for the next 6 months or 7 months. Like, I just feel like, yeah, they're saying we're going to do this, we're going to do that, we're going to force this, we're going to force that. But how many things have they not said in terms of other things in school that a week later, 2 weeks later, just die off.
Yeah. So that's a big cause for concern. We have issues at our school just getting kids to take their hoods off in the hallways. Like that seems like it's a really stupid rule. But let me kind of give you the reasoning behind that. Like, how many people think that's a ridiculous rule that you can't have a hood on? Do you guys understand like the reasoning behind that?
I think it's a dumb rule, but I also know why.
All right. So what do you think the reason why is?
So
Isn't
from
it?
my understanding, it's like because like if an intruder was to come in and everybody's got the hoods on, then they are less likely to be pointed out.
So it's not just that, like not just for like an intruder kind of deal. Stuart, what were you saying?
I mean, you can't identify the student if the hood's on, like from the back or something like that, like key identification points, like hair and stuff like that.
Right. So the way that the way that I spin it, so no, it's not like it's not a respect for anything. Like it's not like, oh, you take your hat off when you're inside, like whatever. The school doesn't care about any of that. It's more of a security issue. So think about it like this: if there was a fight going on, and think about the how many black hoodies, you know, just like black colored hoodies that students wear. Like it's one of the most popular colors, right? So if somebody has a black hoodie on and there was no rule about taking hoods off in the hallway, think about how difficult it would be to figure out the identity of the student. Okay, so that's the first part. But if you're in the hallway, you can get picked out of the crowd because they think that it's you, you know, and then you would go through this whole rigmarole where they're questioning you and you have to deal with all that. And like you going through the traumatic experience of worrying about like, oh my God, am I going to get pinned for this or any of that kind of stuff? Why go through that? Like, why have that? Like, why take that risk? Like, why not just be like, hey, it's not me, didn't do it, and then just get into where you're supposed to be? You know what I mean? Like, even if it's just like a fight in the hallway, you know, because for some reason, whenever there's a fight, everybody just like zooms in on the fight, and it's really hard with the cameras that we've got to see clearly who it is, especially if there's like 50 kids surrounding it. You know, I mean, if it's a group of 10 kids, it's a lot easier. But if everybody's wearing a hood, it's really easy to get lost in the crowd. So, first off, if there's a fight in the hallway, just get out of there. Like, don't get mixed in with that. But like little rules like that, like we have issues with kids not taking off the hoods in the hallway. They don't understand the reasoning behind it, so that's why they just do it anyways, because they're like, whatever.
What
What-
other rules do you
Huh?
feel like?
Sorry,
other
Joanna.
rules-
Hold on, give me 1 second. Let me unlock the quiz for her.
Mm,
All right, and I'm gonna go ahead and end the live stream too.